Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, so our first question here is, what are the three atomic particles' relative masses, charges, where are they found in an atom, and what does a symbol on a periodic table tell us? So first, let's draw an atom with the structure. We've got our protons as those blue dots, electrons as the pink ones, neutrons as those purple ones there, and then those green arrows are for my shells where my electrons live. So, okay, let's have a look at filling this table in. So my protons have a relative mass of 1 and a charge of +1. Electrons have a relative mass of 1 over 2,000. That means that they have 1/2000th the mass of a proton. And neutrons have a relative mass of 1 as well, which means that protons and neutrons have very similar masses and they are much more massive than electrons. Charges, electrons have the opposite charge to a proton, and neutrons, clue is in the name, have a neutral charge or 0. So those are the shells, and remember that actually this isn't a very good picture of an atom. It is mostly empty space. If I want to write that in some kind of symbol, we have this notation here for our atoms where that A at the top, that is our mass number. Remember, that's the total number of protons plus the total number of neutrons. So in this picture here, I have got 4 neutrons, 3 protons, so that number would be 7. The bottom number there, that Z, it's called my atomic number, sometimes called a proton number, and it is just the number of protons. So here, this one would be 3, and it tells me what element I'm dealing with. And then just to make extra sure you know what element that that X there is where you would put the symbol of the element. So this one would be Li because that's the symbol for lithium, which is the element with 3 protons in its nucleus. Okay, so let's have a go at using this notation, and we're asked to complete the following table. Charge on the ion will be shown in the top right, as can be seen by an example there. So you would put the charge on the top right there for your ions. Okay, so let's have a go at the first one. So we have got N147. Okay, so my atomic number, remember that's the bottom number, and so that is 7, and that is equal to my number of protons. Next, my mass number, that's the one at the top, so that's 14. Now remember, my mass number is the number of protons plus the number of neutrons. So if I have a mass number of 14 and I'd like to know the number of neutrons, all I have to do is take 14 minus the number of protons, which was 7. So that tells me there are 7 neutrons. The charge, well, this one doesn't have a charge on the top right of that symbol, so the charge must be 0, which means that I have 0 electrons. Remember, this is an atom because it doesn't have a charge, and in order for it not to have a charge, I must have the same number of protons and electrons. So if the number of protons was 7, my number of electrons is 7. Okay, next one. We have this one here. So my first question is the atomic number. And again, that's easy. I just read the bottom. That's 9, and that's always equal to my number of protons. My mass number, that was the one at the top, that's 19. And my number of neutrons, remember, all I have to do, take my mass number 19 minus the number of protons, that gives me 10 neutrons. Does it have a charge? Look at the top right-hand side. Yes, it does. It has a charge of -1. So if there's not a number in front or behind that minus sign, then that will just be 1. Okay, so how many electrons must it have? Now look at my answer here. I've written 10 electrons. Let's compare that to the number of protons. There are one more electron than proton. Remember here, your electrons are actually negative. So because this is an ion, because it is charged, it has to have an imbalance of protons and electrons. And in order for it to be negative charge, it has to have an extra electron. It has to have gained an electron for it to be negative charged. So it's an ion because it's charged. Final example then, we've got this magnesium here. Atomic number, easy at this point, bottom number, 12, and that's equal to my number of protons. Mass number at the top, 24, number of neutrons, 24, minus 12 protons gives me 12 neutrons. Okay, now looking at the charge, that's quite easy as well because it's literally written down as +2. But just to kind of think about what that means, okay, that +2 charge. So my charge is the number of protons minus my number of electrons. I could think of it like that. Let's think a little bit logically about it. I have a +2 charge and I have 12 protons. If I had 12 electrons, it would be neutral, but I want a positive charge, so I need to get rid of 2 of those electrons, so I'm left with 10 electrons, and it is an ion. Okay, time to do some calculations of relative atomic masses. So use percentage abundances. Remember that kind of means like the amount that there is of each one of these different isotopes to calculate the relative atomic mass of the following elements. And we have this formula here, which looks a bit complicated, but actually it's quite straightforward. As long as I put my brackets in before I complete my computations on my calculator. Okay, so let's have a look at this. We've got some kind of isotope and 30% of it has this mass number of 67 and 70% of it has this mass number of 70. So let me use my equation. Mass of isotope 1, so that's that mass number I'm using, that's 67, times percentage abundance, which is 30 here. So 67 times 30 plus, I just do the same for the second part of this table. Mass of isotope 2, that's that 70 mass number at the top, times 70%. Okay, add those together, divide by 100, and get 69.1. Okay, let's have a go at another one here. So we have got some percentage abundances and some different isotopes. But there's a little bit missing here. So the first thing that we need to remember is that my percentage abundances have to add up to 100, okay, for a particular set of isotopes. So if they all add up to 100, at the minute, that one with 5's got 10 plus 30, so I've got 40% so far. So if I take 100 minus that 40%, I'm missing 60% of my isotopes. So I can first fill that in there. Then I just do the same calculation as what I did before. So 5, that mass, times 10, its abundance, plus 6, the mass, times 30, its abundance, plus 7, the mass, times 60, its abundance, divided by 100, and it gives me 6.5 here for my relative atomic mass.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets and completely for free, so why not?
Okay, tips and tricks for this section. So firstly, don't get confused between mass number and relative atomic mass. So mass number is used for a particular atom or a particular ion, and it tells me how many protons and neutrons there are in that particular atom or ion. But remember, in a particular element, you can have atoms that will have different masses. That is because you can have isotopes of a particular element which all have the same number of protons but have different numbers of neutrons. So your relative atomic mass is actually the average mass of one of those atoms in a particular element, okay, relative to 1/12 of a carbon atom. Make sure you learn those definitions in the topic. Some questions, just to be aware, may use different notation. You might be asked relative atomic mass, RAM, and it's the same thing as that A with the subscript R as well. You're calculating the same thing.